welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about filtering routes using route maps with Prefix-Lists. Before we get into the lab, let's get inside the details and the benefits it provides to your network. So a prefix list is a named list of route prefixes used for matching routes in a routing policy, typically used to filter or control the distribution of network traffic. It's a mechanism to specify which prefixes to include in or exclude from routing protocols. In essence, it's a way to group and manage IP address ranges. Prefix lists support the GE greater and LE less operators, allowing you to match on networks and subnets that have a certain prefix length that is greater or smaller than a certain value. So the purpose, prefix lists are used to define a set of criteria for matching routes based on their prefix, the network portion of an IP address. What about the function? They allow you to identify and manipulate specific networks or subnets within your network infrastructure. So let's talk about Cisco route maps. Cisco route maps are used to control route redistribution between different routing protocols, fine-tune route attributes, and implement policy-based routing. They act as a programming solution, allowing you to match criteria and modify route information. Route maps are particularly helpful when redistributing routes between protocols like OSPF, RIP, EIGRP, and BGP. They can also be used to generate default routes into OSPF. Matching criteria. Route maps can match routes based on various criteria, including network prefixes, route metrics, ACLs, and even BGP attributes. Action on matching routes. Once a route matches the criteria, route maps allow you to take actions like redistributing routes. Route maps control which routes are redistributed from one routing protocol to another. Modifying route attributes. You can change route metrics, tags, and other BGP attributes. Policy-based routing, PBR. Route maps can be used to influence the path of traffic based on specific rules. All right, so let me break it down to you. The first thing we're going to do is we're going to configure router 1 with the autonomous system 65000 using protocol BGP. We're going to also configure the Ethernet 0/0 IP address assign, and we're going to configure 3 loopbacks. And we're going to do a prefix list, and that prefix list is actually going to allow everything except for the 192.168.102.0/23. And on the other end, we're going to configure autonomous system 65001 using BGP. We're going to configure Ethernet 0/0 with the IP address assigned. And we're also going to configure 3 loopbacks, and all 3 loopbacks are going to be allowed using the prefix list that we're going to create. All right, so this is the command line that we're going to be injecting on router 1 and router 2. We're going to configure all the interfaces first. We're going to configure then the prefix list, and then we're going to configure the route map, and we're going to bind that prefix list to that route map, and we're going to assign that to the BGP neighbor. So now that we finished talking about route maps and prefix lists, let's go inside CML and let's get started with the lab. Let's get it, guys. All right, so we're inside CML now. We're gonna start configuring router number 1 with the interfaces, the appropriate IP addresses, prefix list, route map, and also we're gonna be configuring BGP as well. All right, so I'm now configuring the neighbor with the appropriate route map, and that's gonna help me filter whatever networks I wanna advertise from this side to the other. All right, so we just finished configuring router number 1. Let's jump into router number 2. Let's configure the appropriate interfaces with the appropriate IP addresses, the prefix list, the route map, and also we're gonna be configuring routing protocol BGP. Alright, so perhaps you're wondering, why am I configuring a prefix list in the first place if all the networks are being allowed? And why are we using sequence number 2? You're gonna see in a bit. Alright, so we're configuring now the neighbor with the appropriate route map that we created. And as you can see also, BGP is already up between router 1 and router 2. Alright, let's do a show IP route. Alright, so the statement that I configured on router number 1 states that everything that is greater or equivalent /24 is gonna be allowed. So that's why you don't see in the routing table on router number 2 the 192.168.102.0/23. Alright, so let's do a show run pipe session prefix. And the statement states 192.168.0.0/16, but I'm gonna take only what is greater or equivalent /24 all the way to /32. So this is why the /23 running on loopback number 2 is not permitted. So now I'm gonna configure a new prefix list entry with the sequence number of 1, and I'm gonna deny the 10.0.0.0/24 to be advertised via BGP from router 2 to router 1. And this is why I configured the route map with the prefix list in the first place. Because if I want to deny one of the networks that are already being advertised from router number 2 to router number 1, I can accomplish this by doing a sequence number of 1 before it hits sequence number 2, and I can deny that network. Let me show you. Alright, so let's do a show IP route on router number 1, and as you can see, we got all the 10 networks already being advertised from router number 2 to router number 1. Alright, so let's do a clear IPBGP asterisk soft out, and let's verify the routing table again on router number 1. And as you can see, the 10.0.0.0/24 is no longer available on the routing table. So this is all for today's video. I hope you enjoyed the content. If you did, please give it a like. And as always, this is Network J. I'll see you in the next one. Peace out.